Carpe Diem VPN. Seize the network.
Hey everybody, it's Tim with Carpe Diem VPN, and I'm here with my good friend Chris Miles. We're going to be talking a little bit about SD-WAN and specifically some SD-WAN design stuff. If you've seen any of my prior SD-WAN design videos, I was talking about some of the considerations we have to think about when we're doing our SD-WAN design. And Chris and I have been friends for a long time, and we know each other really well. We know each other. We know SD-WAN pretty well. And I just invited him on here to talk with me about some of the SD-WAN stuff. So, how you doing today, Chris?
Doing good, man. Thanks for the invite. Appreciate it.
Yeah. So, Chris, are you a architect with WT? Is that right?
Yeah, so I'm basically a network domain architect. So we do a lot of pre-sale stuff, a lot of post-sale stuff, but we're a pretty big integrator, so get a lot of hands-on.
Cool. And I doubt anybody doesn't know this already, but I'm also an solutions architect with Cisco, and um, been working with SD-WAN for, well, pretty much since we acquired them a few years ago. So, and Chris, I know you've been working with them as well for just about as long, right?
Yeah, it's been about 2 years. As soon as I came on at Worldwide, I was put right away into a SD-WAN project. So it's been my bread and butter for a little bit.
Awesome. And have you done a lot of deployments for customers? And
I've done two major deployments. The first one was a fairly large global deployment, so that was really nice to get thrown right into something
yeah,
that was at that scale. So I did get a lot of exposure there. That one was actually, well, it was global, pretty small, only 60, 70 sites, and then I just did another one for a restaurant that's was about 1,200 sites, but all in the
oh
U.S.
wow.
So very different, very
Yeah.
different dynamics. Yeah.
Absolutely.
Mhm.
Yeah, and of course when I was doing CPOCs, I would get the same gamut, right? I'd get some where people bring in labs that were, targeted for 50, 60, 100, few hundred deployments, and then I did do a few where we're talking global companies with thousands of sites, and
Right.
it's a very different conversation when you start talking about that kind of scale, right? In terms of the design, architecture. And so we're here today specifically to talk about control connections. We're gonna give an overview of the lab that we're working with. We're gonna talk about SD-WAN just a little bit. We kind of expect that if you're watching this, you probably know a little bit about SD-WAN already, or at least kind of the basics of Cisco SD-WAN. I should quantify that because I said something the other day on Twitter about learning something new about how SD-WAN works, and somebody replied correctly. I'm not calling them out, and said like, hey, it's different per every vendor, and I'm like, well, okay, yeah, you're right. You're absolutely right. I was talking about Cisco SD-WAN, but you're right. It is different per vendor. So I want to quantify that, right? We're talking about the Cisco SD-WAN Viptela, not the Meraki one. So let's go ahead and I guess just dive into the lab here. I'll share. We can mark up the board a little bit together and just talk about, like I said, kind of an overview of the lab, what SD-WAN is about at a high level, and then specifically like what are our control connections for, and what are the design things that we have to think about when we're building them. So let's just get right to it. All right, so here we have a diagram of our lab setup, and I'll just quickly go through it. Again, some of this was in my previous videos about SD-WAN design specifically for this lab, but just to level set and get us all on the same page, let's talk about it. So in this setup, we have SD-WAN controllers for the entire fabric that are going to be sitting in the Cisco hosted cloud connected to the internet. We'll have two internet providers. You can see I've marked them as Biz Internet and Pub Internet, but this could be AT&T or Cox or just two different internet providers of any kind. And then an MPLS cloud, some kind of private circuit. Now, we have two data centers, a DC1 at the top left, DC2 at the top right, and some kind of DCI or interconnect between them. Now, this could be layer 2 fiber, this could be OTV, this could be provider. There's a lot of different options here. So that's something we'll talk about in a future episode. On the left here, we have a legacy site. Now, this legacy site represents basically our prior networking So normal BGP connectivity with an MPLS provider, no SD-WAN here at all. We're assuming we're going to have SD-WAN in our DCs, and there's two SD-WAN boxes in each DC, and then a core router. And then at our branches, we have just different kinds of branches, branches that have different kinds of connectivity, and just different kind of routing and just architecture in general. So as we understand, SD-WAN in general is based on the idea of being able to simplify and maximize the WAN bandwidth that we have, right? We want to be able to simplify the routing over our different disparate transports, and we also want to be able to, should we choose, utilize each of those transports as best we can, as for the whatever sense it makes to do so. But ultimately, every SD-WAN box has to be able to talk back to the SD-WAN controllers in some fashion in order to get its programming, get its config, get its policies. So, Chris, would you like to tell us a little bit more about just control connections in general, and then we'll kind of take it from there and talk about this particular lab and what problems we might run into?
Sure. Yeah. So, I think a strong fundamental piece of any SD-WAN solution is a focus on a decentralized control plane. The Cisco implementation of SD-WAN is no different than that. So as you've kind of shown on the diagram here, over on this side is where, let me get the pin out. Over on this side is where we have those controllers orchestrating different functions here. So we have the vBond, the vSmart, and the vManage. So won't go into each one of those, but basically each one of these serves a different role in the SD-WAN controller set here. vBond is primarily used for initial onboarding and orchestration. vSmart is used for the distribution of policy, routing, things like that. And then vManage is kind of your centralized control plane that you, centralized.
The management plane?
Yes, management plane to, thank you, to facilitate all this. So control connections obviously are the concept of how all the data plane devices shown across here, let's see, router here, at any of these sites, they all need to maintain an active connection to these control plane elements to make sure they can participate in the SD-WAN fabric. So let's say this router here that we got here in the top right corner, if he's coming on, he's going to join the SD-WAN fabric for the first time. His first thing he's going to do is try to reach out to this vBond that's over here. He's just going to talk to the vBond, basically get validated, make sure that he's allowed to join the fabric, and then the vBond's going to tell him, okay, here's the rest of your controllers you need to initiate control connections to. So then he will then start forming the same connections over to vSmart and vManage, and pull down his config, his policy, all that. And all of these connections are going to be based on DTLS or TLS.
Right. Okay. So DTLS is dynamic TLS, of course, right? But
right.
So people, I always get this. I get this question a lot because DTLS for some reason is still not as well known as like what it kind of originally evolved from, which was like SSL type of connections. So so DTLS, TLS. So obviously, what's the big difference between DTLS and TLS in this case for our purposes of control connections?
Yeah, so really the only major difference is one is going to be UDP based and one's going to be TCP based.
Okay, makes sense. And I assume it's the TLS that's the TCP one.
Correct. So TLS is more of your typical TCP based. So if you have something, basically some hard requirement where you need that traffic needs to be seen two ways, or if you need to do a stateful session on that connection, you're probably going to go to TLS.
Right. Or if you just have to pick specific ports for some reason, you can't do dynamic or something like that. So you have an InfoSec policy or something like or some
Sure.
firewall or something like that. Okay, cool, 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 cool. Okay, so awesome. Let's think about this then for a second. So in our setup, what I'm looking at is that since all of our boxes are all of the management vManage, vSmart, vBond, everything's out in there in the internet cloud. Obviously, the only way to reach those boxes is going to be over some kind of an internet connection, generally, right? I think so. So there comes our very first, I guess, design constraint or design consideration, right, for
Mhm.
that. And so let's see. Like, I kind of want to like keep it. I kind of like mark that down and just like be like it has to be like number one or not number one like most important, but just like the first thing that probably we have to think about, right? Is like it's like number one. If I can, no, I can't. I can't draw. Hold on, this is like my pen just like freaked out on me here. Hold on. See if this will be better. Okay, try that better. So like number one is simply that we can assume, given this setup, that MPLS is not going to be able to get to our controllers, right? That's give as written or as drawn, right? We can. There's an assumption that generally, unless it's something like Verizon, where they can do some stuff on the back end to merge their MPLS connectivity with their internet offering or something, that generally speaking, a private circuit has to have some other way to get to
Right.
a
Like maybe if
controller.
they provide some kind of internet gateway service or something out
Yep.
of the MPLS cloud. Yeah.
Exactly. Just like I believe Verizon does that specific thing for Verizon to Verizon, like MPLS Verizon to MPLS
Hmm.
Verizon MPLS or internet. So okay, so that's like number one. That's like design consideration number one is we have to think about for every transport we have, what can we build control connections over? Okay, so cool. That's just like number one. Um, what else do we have to think about here from a control connections perspective? Given so like I'll just pick some branch at random here or some setup at random, and let's just like kind of think through what our options are for building control connections. And you can see so for branch two, for example, and I'll just look at it here. So for example, for branch two here, you can see that it actually can build its control connections to the cloud, multiple ways. Um, so it does, right? If and correct me if I'm wrong, but the default behavior is that any box, any SD-WAN box, will try to build control connections back to the controller over every and all um, transports that it's connected to, right?
Right. Yeah, that's what I was going to say. Another big consideration is unless you tell the box specifically not to, it's going to try to build those control connections over every transport, and a default behavior is going to be if if you cannot establish control connections, you don't build tunnels to other SD-WAN elements in the fabric over that specific transport.
Right.
So you're going to have to be considerate of that in your topology.
Yep. Yep. Absolutely. So let's see. So for example, let's just actually I want to clean this up a little bit if that's all right. Clean this up a little bit, and because we talked about this part now, I want to give us some space to draw some more
Hmm.
lines.
Yeah.
Um, so like so then just pick on another example here. So like look over here at branch one. Here we've got this guy. He's connected directly to the MPLS, and this guy's connected directly to the internet. But we see that we have a TLOC extension between them. So what so basically, given this type of setup, which is extremely common, I think, in deployments, right, is that you'll have some kind of, for some of the larger offices where you might be running an internet circuit and an MPLS circuit, it's pretty common at the WAN level to see them connected redundantly in this way.
Hmm.
So, given that right now, until we have to decide whether we want to or how we're going to do MPLS controller connectivity later. But like given that, so what's our design? Like what considerations or what thoughts do we have about how, with no changes, how this branch is basically going to connect back to the controllers or be able to connect back to the controllers?
Yeah. So, I mean, the first thing you're talking about with the dual router design, correct?
Yep. Yep.
Yeah. So yeah, dual router design, typically at a branch, you are going to use, just as Tim noted here, the TLOC extension option. One thing that is pretty common, I assume most people, when they deploy MPLS, are doing L3 VPN on their topology here. So one important element is this interface right here on the router on the right. That is his tunnel termination point, or where he's going to use to build control connections. So if for anything to route over to the MPLS, whether he does backhaul and make it all the way over to the controllers on the right, or he's just building tunnels between other sites, everyone needs to know about this link here. All right. So if there's a transit /30 that's configured here, you need to make sure that this guy advertises that in some capacity out to the MPLS to make it a known network, so they can build their tunnels to it. So that's going to be a peering that is established in the front door VRF, aka VPN 0, where all your underlay connections are. And you can do that with probably BGP, or if you really want to get very I guess complicated with it, you could have the MPLS provider maybe do static routes for you if they'll do that. But I think your most common element there is going to be BGP to advertise that network out.
Yep, absolutely agree with that. And like you pointed out, is irrespective of whether or not we can ultimately build the control plane back to the controllers, it's needed just for even normal branch to branch over that transport connectivity.
Right. Right.
Exactly right. And actually the same, you can bring up a good point, because the same is true the opposite direction. Right.
Correct.
So the branch 1 router here, this link, whatever that is, has to either be some public space that's owned and able to be advertised or something. Maybe it's provider independent, maybe it's not. Maybe the provider's offering like a /27. If I could draw here. It's nice. What's sad is that I'm the one with the tablet. So like say like they offer a /27, you could chop that further up into say 2 /30s or whatever, and route it that way, and then the provider would route that to this link. Or the other option is if you just have, say, one IP from the provider, you could always use NAT, right? You could NAT for that TLOC extension. And I realize we brushed over TLOC extension because it's not a huge part of our... It wasn't a huge part of what we were talking about, but maybe we'll double back and just talk a little bit about TLOC extension for anybody who's not super familiar with it. But I don't want to lose the thread here. But yeah, it's the same. It's exactly the same concern, which is that these interface IP addresses are tunnel endpoints, right? Just like if you were building a site-to-site IPsec tunnel or something, if you're going to have that IP be the tunnel endpoint, that IP has to be reachable over the transport, right? Yep. So that's how the control connections, in this case, we know the control connections would work the same way because it's over the internet and we would reach the controller cloud, right? But we have options based on what space we do or do not have. We can either NAT on this router here through the TLOC extension, or if we have extra space, we could allocate. We could chop up our, say, /27 or whatever it is that we were given, /29, or as long as we can actually chop it up, we could chop it up and do it that way as well. Right. So let's step back for a minute, and I don't want to do like complete primer stuff necessarily on TLOC extension, but I think it's as important for a control connections discussion as anything else that we have here. So would you like to take that? Would you like to talk a little bit about the TLOC extensions? That'd be awesome.
Yeah. So let's clean this up a little bit. But yeah, so with the TLOC extension, I guess I'll take it back even further. One of the important elements to the SD-WAN solution here is each one of these routers, just for full visibility of the network and full reachability, he needs to be, and speaking from the perception of the router,
right.
They need to know about all available transports at that particular site. So while you may have an MPLS cloud and you have a DIA connection, you're only probably getting one handoff from those providers, right? So you terminate that on one of the devices, and then if you think about it that way, then each router has their locally connected WAN, but they don't know about the other guy's WAN, right? So that's when this TLOC extension comes in. This can be one interface. It can be, one interface with multiple sub-interfaces built on it, or it can be dedicated interfaces if you really like wasting cables. But
which one do you see more in the wild? Sub-interfaces?
Definitely sub-interface, yeah. These are typically always 1 gig interfaces, and you rarely see
a gig on the WAN. Yep.
Right. So it's usually fine just using that.
Yeah.
But I think so. You have the color coding here is good. So the MPLS connection is the green line, and then the biz internet is the orange line. So if we're talking about from this guy's perspective here on the left, he has his green northbound connection, which is in VPN 0 to the MPLS. That's where he's going to build control connections for that transport. The color is probably labeled as MPLS. And then his orange line going east and west is the secondary WAN that's been extended to him from router 2 over here.
That's right.
The beautiful thing about this is from this guy's perspective on the left, BR1, he has no knowledge that second connection is a TLOC extension. Yep. He just sees it as another WAN interface, right? And he knows, I build tunnels this way, I build control connections that way, and I think that's been a very tough thing for a lot of customers I've seen to grasp, what the TLOC extension, what its purpose is, and how it functionally looks. When people are building templates and things like that, I see this commonly, like everything's labeled, like they'll build feature templates like labeled specifically TLOC extension for their WANs and things like that. And I'm like, you don't need to do that. You can reuse the same WAN templates all over the place because this guy on the left does not know that. And the same constructs apply to, the biz internet connection, whether it's a TLOC extension or it's directly connected 90% of the time. There are different variants that come into play, like whether you're doing DIA and NAT and tracking DIA and things like that.
Yep.
But in the opposite direction, it's the same thing. Router 2 is extended that MPLS connection from router 1. And the way this is done is that you can apply a template to, let's say BR1 over on the left. The BR1's the site name, but router 1 at branch 1. He is going to have a configuration template applied that says, okay, let's say this comes in on GE01. I'm going to have a config that says, okay, extend that to this interface, which might be, let's say that's GE03, and it's probably a sub-interface, so .100, right?
Yep.
And basically just says, I'm going to allow initial or extra, basically, control connections destined for that interface on the opposite side of this to flow through me as if they're just one logical connection, right? And the same thing happens on this guy for the on branch 2, router 2, to extend the biz internet over to router 1.
Yep, absolutely. And we have to do, and if we're going to extend TLOCs, we have to do that because the routers are hardened on those VPN 0 interfaces, right? By default, we don't actually route packets for other routers through that interface, right? So what I see a lot, it's funny when you mentioned about it being a source of confusion. What I see a lot, or what I saw a lot when I did CPOC, was the hardest part of explaining that part, or when people started playing with templates, is that they would want to mark the TLOC they were extending as the TLOC extension. They would want to check the box for TLOC extension. I'm like, no, or I'm sorry, not that they're extending, but that they are extended. That's coming towards them. And as you pointed out, is actually from their perspective just another WAN interface. They would want to mark it as the TLOC extension. I'm like, no, TLOC extension specifically says I'm handing off this interface to someone else. It's not, from the point of view of you, that's just another WAN interface. So that's a very good call out. That's a really important thing for people to understand. So spot on with that, with all of this, right? So from a control connections perspective, I think we've definitely started digging in a little bit on like what are the things we have to think about when we're designing our sites. And I've got different sites here with different type of setup here to kind of illustrate that, like how are we going to build our connections. I want to jump up to the data center for a minute because firewalls are definitely a huge thing to consider as well, right? When we're building our control connections. So as an example here, so say in DC1, we'll just say like this is 1 and this is 2, like you did before. And you see now in this case, what I've drawn in the diagram is that I've got like each color has like a different interface. I don't even know if it's truly that way in the lab. It might actually be sub interfaces, yeah. But because and it matters, right? Because as you've observed, the sub interfaces uses less cables, and honestly, the only reason we would want to break out these cables, generally speaking, is because we have a sufficient traffic that we will be concerned about stepping on each other's color as we're pulling in and sending out packets, right? So I think that's an important consideration as well when we're designing how are we going to connect to everything is thinking about that, right? Because a lot of people are like, oh, well, 4 colors on one sub interface and we're good. And then they realize that they're pushing out over a gig of traffic over one of their interfaces, and they're just like starving all the other colors. It's right. So definitely. But anyway, getting back to this point about the firewalls, though, when we're building again, now I think it's an important thing to mention also that the router has no idea there's a firewall in existence, right? The router is completely unaware that there's anything natting or changing anything about the packets it's sending, right? You'd agree with that? And then, yep. And that matters because actually I would love, so I was thinking about it, but when I'm done, let me come back to you here in a minute because I'd love to, because I think you'd be able to explain this really well too. The point is when the packets, if you will, the control connection packets come out here, the router's sending it with whatever IP address is the sources that it's assigned. So if it's assigned a public IP, it's going to send it out with the public IP as the source. And you can see actually I've pointed out this to be the case here. So this is a no NAT DMZ, and then over here I've got a NAT DMZ, right? So here we're assuming that our WAN routers are in some kind of a DMZ where they're being allocated public IP addresses, right? The firewall is still providing security, but it's generally just switching packets and inspecting the traffic, right? So here, you can see the public, you've got a packet, it comes out, we're being routed over, to whatever internet color that the firewall is then connected to, because the firewall has to be connected to either directly to either directly to the internet or to, more commonly, right, there'll be some kind of an aggregation switch or some kind of aggregation layer where we're bringing in multiple transports and stuff. And actually, that's one more thing. I want to put a pin in this because I don't want to forget it. And I just want to write it down real quick. I just went off on a tangent there a little bit, but it brought something that it was something that I thought before the show, like I really want to talk about this because it's a huge deal. But I just remembered when I started talking about this, right? Visibility into transport routing.
Oh yeah.
You know what I'm talking about? You can already see where I'm going with that, right? So when this packet hits the firewall is going to be responsible for making sure that the color stays intact, is what I'm talking about, right? So if I send it out on biz internet from the router's perspective, damn, it's done. It's on the biz internet color and everything, and all's right with the world, and we're going to build IPsec tunnels, and they're all going to go over biz internet and control connections too, actually, right? Mm-hmm. Yep. So what if the firewall just has one floating or one default route that just ECMPs over all available paths? What's going to happen, right?
Yeah.
Have you seen that in the wild? I haven't actually seen it in the wild, but I think it's a clear and present danger to a lot of organizations that don't just know better. Like they don't maybe.
Yeah, I didn't. No, I have not seen that. I didn't think about that, but it makes perfect sense. If the device behind the firewall is thinking each one of these connections is tied to a dedicated specific transport that has this behavior, and then the firewall is potentially sending their traffic over 3 different transports. Yeah, that's not going to work. Yeah, so wow. That's I'm glad I haven't run into that. It sounds bad.
Oh, I mean, I've been in organizations where this was a normal strategy to have whatever their egress firewall is, simply load balance the traffic over, whatever PAT, if they're for their interior PAT, or they'll do a one-to-one NAT or something like that. They'll statically set it. So the point is, you wouldn't want it to just happen there. If you were gonna, you would want to make sure you're pinning the traffic correctly. And that comes into play maybe a little bit more on the NAT side than the no NAT side, because on the no NAT side you're going to have a public IP, and that public IP will generally be tied to something, some transport, unless it's provider independent.
Right. I feel like with the NAT DMZ, you're probably going to be a little safer from that behavior for sure.
Interesting.
But yeah, I guess so. What like I'm curious. What are you if they are running into this scenario with the no NAT DMZ? How are you getting to pin that? To like a policy route or?
Well, so if you think about it, right, we've handed off all the decision making to some other device. So the SD-WAN is no longer really making the routing decision on the how the control connections or even the data plane is being built. So it's up to you to figure out, because generally we talked about this, right, versus multiple cables per transport versus sub interfaces or whatever. My thinking is, and I'm kind of curious what you think, is that when it comes into the firewall, it's coming in on a specific interface. And so, you could, depending on what kind of routing you're doing, you could decide that, static route from this interface to this interface, or set up that's how you would do it, I think, is set up your routing so that you're pinning it to go out. So like, source IP this, destination IP this, use this interface. Like, I'm thinking out loud now about it. So I don't with the no NAT DMZ, it depends. If you have provider independent, meaning you own the space and you're advertising your space to multiple providers, right? I think you're actually in that case, you might actually be in trouble anyway, if you think about it, because your packets could come back to you over multiple transports. So I think that might actually be a danger. It's something I hadn't considered until just this moment, and it's something we should tackle. Maybe I don't want to spend too much time on it, but it's something I've just, as I've peeled the layer back, as I started thinking about it, it's something I hadn't thought about before.
Yeah, I mean, it sounds like something that don't get me wrong, it'll probably work, but there's going to be really weird scenarios where things fail and you don't know why they fail, probably.
Yeah. So having control, having visibility and control of how your packets are routing over each transport, I think is almost a table stakes for an SD-WAN deployment, right? Would you agree with that generally? So
yeah, for sure.
Yeah. So and this only starts to become tricky when you're you're dealing with some other device that's making the routing decisions down the line, right? That may be aggregating multiple transports, and you just have to make sure your decisions are being made in a way that pins the traffic, I think. So anyway,
right,
sorry.
Because that comes back to another kind of like default behavior in the Cisco SD-WAN world where, as devices join the fabric, no matter how many transports let's say you have router A at site A and then router B at site B, they're going to try to build tunnels over every combination of those transports that they can. So
that's exactly right.
It grows exponentially how many tunnels they build. So if you have kind of these provider independent networks that can be routed over multiple, you might be mixing and matching and not even knowing that you're doing it.
Right. And to me, the way to fix that, I was already thinking about like ways you could solve that, because there are going to be a lot of good size organizations out there that have to contend with that, right? And so if you own provider independent space, generally you own something bigger than a /24, but at least a /24 or something like that, generally. So what I would say you would do in this case is probably you would carve it and then advertise specific subsets of that to each provider. So and then tie it back to your SD-WAN boxes. Does that make sense?
Yeah, it definitely makes sense. I just think I'm not usually in that space, fortunately for me. But are they going to let you advertise anything smaller than the /24?
Oh, that's a good point. No, that's fair. That's something I thought about. It's funny. When I was at Cisco Live a couple of years ago, I think this came back to mind because I was doing MTEs. And there was a customer there who was facing down this exact problem. Because it just popped back into my head. This is the exact problem the guy was running into. And I think his plan at the time was to actually work with the provider and get provider space for this. Because that would be tied to the specific provider, not provider. He basically, his decision was based on exactly what you said, which is right, which is most providers are not going to allow you to send less than a /24 to them. Although I think that
Right.
I read somewhere that that's changing, but I hope not, because God, the tables are already large enough, right? But anyway,
Yeah.
I think his solution was going to be to get provider, yeah, I just lost my train of thought. The not provider independent, the one the provider gives you
Yeah, I
space.
mean, I think for this use case of SD-WAN, you probably don't want provider independent because I feel like that's usually
That's for like web
that
services and stuff where you're hosting a
right, something you
service.
want to remain static. Here
Yep,
we don't care that much about that. We're just
exactly.
using the underlay to build the fabric. We don't really care who it's going through, who's doing what. We just
No,
want it to work.
that's exactly right. So when we're talking about organizations designing their WAN, that's definitely something to keep in mind. I would say is that even if you own that PI space, I would agree 100% with you. PI space actually would get you in trouble here,
Right.
right? I would think. Anyway, so I don't want to spend again. I don't want to. It's just something that came up, and I wanted to dig into it a little bit because I think it is important. Because whether it's IPsec or control connections, it's still the same situation in that case, right?
Hmm.
And then, so what I want to do is I want to talk a little bit about our solutions, possible solutions. One of them being that we simply just don't do MPLS connectivity to the controllers. But let's talk about some of the other solutions that I kind of brought up before and maybe walk through them a little bit. Let's switch over to that screen. So I'm going to pause for just a second and let me switch over to that screen and I'll just bring it up and we can kind of talk our way through some of the options here. Okay, Chris. Well, we can't solve every problem for everything, but let's talk about I think how we would solve or actually multiple ways because there always exist that we might solve the MPLS connectivity problem, and we should right out the gate say one of the ways we could solve that problem is simply to just not allow control connections uh, over that transport, right? Like maybe there isn't an answer. Maybe we can't provide that connectivity. In our lab, at least, we're lucky enough that every site has at least one internet connection. So maybe that's just the way it is. In real world, though, I mean, as you know, there are definitely some sites, some small sites, especially where you find you can only get like a private circuit or something like that. So let's talk about that for a minute. What are some of our options that we could solve the MPLS connectivity problem?
Sure. So, yeah, I think the first thing you can do is, you backhaul that traffic from the MPLS to a site that has connectivity to the public internet to allow that connectivity to be established from the branches to the control plane. But one thing that we'll get into when we deep dive on these SD-WAN devices don't actually function like a normal router, right? Like you said, they are hardened devices. They're not really means to just use for transit routing,
They're
which we've been
right.
doing for years and years. So it's kind of hard to get that through get that in your head.
Yeah.
That's a big point where I see a lot of customers struggle with that concept. It's just like, well, it's just a router. It's not. You've kind of changed the functionality
It's absolutely true.
of these interfaces to do something else. So your tunnel, if you're terminating a tunnel on an interface, it's not going to be used as transit. So that's probably the best way to look at it.
Yep.
So instead, you could terminate the tunnel somewhere else. So it could still go to that local device, but maybe you have like a loopback that is known by the entire underlay. You can build your tunnels that way, and then the actual ingress interface that it comes in on can be used as transit. So your traffic from the branch hairpins through the DC, goes out to the internet, but all the tunnels are terminated on that loopback. So that's one option.
Okay.
You want to go over the second option?
Yeah. So what I've seen other people do is, and what you mentioned about having a site where you have MPLS and internet together is that's really the answer. It's just a matter of how are we connecting the two, right? So one of the other options is that we simply have a router that connects to, say, the MPLS on the underlay. We don't bring it into the data center proper, right? We don't bring it into what we would call the service side or the VPN or service VPN or just the SD-WAN piece of it. We keep it completely isolated, and then we, kind of move it over in some way to some sort of internet egress. Commonly, you'd throw it over to like another interface on the firewall or something like that, and let the firewall do some kind of NAT. Because if you're going from a private circuit to public internet, somewhere along the line, there's going to be a NAT involved, right? So whether you put it on that router itself and connect it one leg here, one leg there, or if that would be kind of weird. You would definitely more commonly see it through like a firewall stack or something like that that's got security connected to the internet. But absolutely, right? The point is that you're not bringing into like the core and then trying to route it out, through the internet that way, because that becomes really messy when we start talking about underlay overlay routing. But yeah, that would be another way we could do it.
Yeah, I honestly that's kind of my more preferred option, but obviously it's the least cost effective because you need dedicated devices at these layers, right? But I think it's much cleaner to segment things that way, especially in your data center. If you have just like a WAN services layer where all your WAN connections come in, then you can kind of put the SD-WAN box behind that WAN layer, and it's treated as a dedicated service. This is your on-ramp to the SD-WAN fabric. These guys are to help build your underlay or facilitate backhaul internet traffic if you need that functionality. Like I said, it's much cleaner that way, but less cost effective. And when you're doing refreshes and things like that, there's multiple considerations. But budget. I mean, if your SD-WAN device isn't providing that internet backhaul or that underlay connectivity like that, I think it's easier to do maintenances on these things in sections and stuff like that. But
Yeah, I would totally agree with that. And we'll dig in on that here in the diagram and walk through that a little bit. But I completely agree with you. Loopback as TLOC is effective. It works, but it's a little bit of a brain bender, and it's a little dirty in terms of complexity and segmenting. In my opinion, that's just my opinion. But yeah, so you brought up another one that I hadn't even thought of. And I don't know how serious you were about it, but I think at least it bears discussion a little bit. The LTE one.
I mean, if there's anything we've learned from going through CCIE, it's like you've got to build what you can with the tools you're given. You might be given a fort to build an enterprise, but you can do it, right? So yeah, this third option that I've thought about, I don't know if anyone has done this. It would be, so let's say you do have a site that's connected only to MPLS. You don't have any options for an internet transport to be put there. If you really want to have that function, you could put something out there like an LTE connection, maybe, I don't know, like a cradle point, something to terminate it, or you could put it on the box itself if it functions that way. Build an LTE connection to the internet, basically establish your control connections, pull your policy, pull your config, pull the template, all that jazz, right? And then you can have your policy built to say, okay, LTE was used just for that purpose. Don't build tunnels over it. Don't use it as if that's what you're looking for, right? You don't want to use that as an actual transport. Then the router at least learns the context from vSmart and vManage. This is how I need to build a topology over this transport that has no external connectivity, right? Yeah. So then you get into this weird concept of like where your dependencies are. If LTE, kind of takes the shit, right? You're then you're kind of dead in the water to an extent. There's a concept built in to the Cisco SD-WAN called graceful restart, whereas if my control plane is completely lost, I'm going to operate with my last known good configuration for this preset amount of time. If you're doing that, you might want to set that pretty high just to make sure, the cell towers get taken out in that area for, over a day or something like that. You could be in trouble. But again, we're talking about a corner case here, so it's probably not that common, but
not the normal deployment. Certainly, I think you would see it maybe in more remote areas, possibly. But there, you wouldn't probably be able to bring in. You may or may not be able to bring in a private circuit of any kind, and an LTE could be your only option. Like in that case,
right?
But I was thinking for like LTE you could set it up as a last resort circuit, so that at least you have the option to use it as a data plane if you need to. But with last resort circuit, you're just not. it's just dead, right? It's dead until the other tunnel fails, and then it'll try to build. But it's metered, right? That's the problem with LTE.
Yeah.
The LTE is
Yeah.
metered. It costs money. So
Right. Well, I think the problem also with if you configure it as last resort circuit, I think if I recall correctly, that functionality stops anything from using that connection. So I don't even think you build control connections when you have.
Oh, you're right. No, you're absolutely right.
So
That's correct.
you would constantly going into graceful restart after.
No, you're completely right. I forgot about that.
Yeah. So, but you could configure it, like I said, as a low bandwidth circuit.
Low bandwidth.
You could build your policy to say, don't even advertise this TLOC out to anybody, so that no one tries to build a tunnel to it. I don't use it except just for the control policy.
Oh, that's exactly right.
Yeah.
I hadn't thought about that, but yeah, no, that's in this particular because of course when you normally roll LTE, you're rolling it as a backup connection, and I forgot our context is specifically about just how to roll our control connections.
Right.
And that's a very good point. It's a very good point. So yeah, you do your other stuff, right? You turn the BFD like all the way up, the BFD timers, all the not BFD, sorry, the control connection timers all the way up. You set your vManage connection preference. Not that it matters, since that's your only way to connect to the vManage anyway. But should you get another circuit later on, it's probably just best to set your vManage connection preference like really, really, really low, and then just for future proofing. And then just turn the timers up as high as you can get them, pretty much with that type of setup. And there you go. So that is an option.
If you're worried that much about that metered connection, you probably want to make sure you're not doing any kind of logging up to vManage that direction either. You probably want to send that somewhere else.
You're going to need somebody to go on site to, dude, you're going to need somebody
to pull your logs manually.
Well, that's a good point too. Now I was thinking of to upgrade the box. You're going to have to send somebody out there with a USB drive. You don't want to download. You don't want to do an upgrade over the LTE or a few hundred megs over the LTE, right? So
if you choose this option, operate at your own risk. You're signing your own.
Yeah.
Your own.
That would be a true corner case. All right. So let's jump over to the diagram. Let's walk through our options, and then we'll wrap this up, dude. This has been great so far. So give me just I'm going to swap over.
Cool.
All right. So let's see. So we pulled over basically an approximation of the problem, and this should look familiar from other video. It's basically the same setup here. And what I want, Chris is going to cover the loopback as TLOC, and then I'll talk about the underlay one, and we'll kind of close it out from there. So, so take it away, Chris. How would we get this? What's the loopback as TLOC option we could do to get this working?
Sure. I think as we touched on before, the concept here that we're trying to get rid of is the fact that here we have the branch here, and then he needs to talk to the controllers out here. Right over on the right-hand side. So MPLS not having that connectivity to the internet, we need to actually funnel this back through the DC router here, right? So we need to change the functionality of this guy building tunnels from this interface here over to this interface here. Because if this interface up here at the top is used as a tunnel termination point, he's not going to allow any kind of transit routing through him, right? So we kind of need to change that behavior. So what we're going to do is instead we're going to attach a loopback. Maybe we'll call it loopback 100. And this is now going to be his tunnel termination point. Yep. So obviously there's probably other branches connected to this MPLS cloud. So as they build tunnels, they're going to go back and build them to this point here up at the top, right? They're not going to do it on the direct interface. So now this guy down at the bottom, branch 1, SD-WAN 1, as he is getting onboarded, he's going to establish his control connections. First it goes out to the MPLS cloud. Then it's going to probably follow a default route that's being originated by the DC1 SD-WAN router up here. Then the traffic's going to go up there. And then he can funnel that either out through public internet or biz internet, but regardless, makes it over there to the controllers.
Now, in this setup, what we're missing, of course, is is a box that's going to NAT us. Now, it could be the SD-WAN router, or the SD-WAN router could route it to like a firewall stack or something, right?
Right. Good point.
To get it to that. Now, which do you? First of all, do you see this in the wild? And out of curiosity, and then I guess my follow-up question would be, how do people in the wild usually handle it? Do they just hairpin on that router and do it like a NAT on the interface there, or do they actually route it out through a stack on the underlay, like a security stack on the underlay?
Yeah, it's a good question. I've definitely seen both. I definitely probably see more so a firewall sitting at the internet edge so they can perform that NAT functionality there, which obviously makes our job much easier deploying this. You can do, like you pointed out, you can do it on the router, but that just adds, I think, more complexity to an already relatively complex solution here. So I would try to avoid it if you can, but obviously you got to do what you got to do. So I definitely see the option where there's a firewall in the in front of the internet connections, providing NAT functionality more often.
So then we just need to make sure that the SD-WAN box in VPN 0 has that default route that points it at the internet, basically. One of the internet or the firewall, whatever it is that's going to be ultimately natting for us. Yep, that makes perfect sense to me. Makes perfect sense. Okay, so let me clean this up a little bit because I think this is an excellent explanation, and I just want to have a little bit of space to show the other option. So I'm just going to clean up a little bit here, and then so I can draw my own stuff in. Okay, so we talked. So that is one way to do it, and you can see, I think, what Chris and I talked about a little bit earlier, where it's a functional option that keeps you from having to buy or use more equipment, but it definitely increases the complexity of tunnel terminations. Because one thing we forgot to mention, which is important, is that you have to make sure that loopback 100 is advertised to the underlay. In the same way that when we were talking about TLOC extension, it was the same thing, right? Anything that's not directly connected needs to be advertised, more or less, into whatever underlay. So that's a good point. So another thing we could do, and again, this is more of a if you can, this would be the way to do it. This would lower the complexity type of way to do it. Would be to drop an underlay router. So like we'll call this an MPLS underlay router, say in the same data center, and it would be connected to to say, our firewall, just like we were talking about before, and that would then be connected to these other ones. So what would happen is that, when branch SD-WAN tries to connect and onboard itself to the vBond, it's going to follow this default route through MPLS, which is coming from the data center. But in this case, instead of coming from DC SD-WAN, it would actually be originated from our underlay MPLS router, right? And then our underlay MPLS router would basically do the same thing that SD-WAN did in our previous example, and it would then pass that route or pass that traffic on to the firewall, which would provide the NAT to get us, connected over the pub internet back to our controllers, and that's how the reverse traffic from the controllers would come back the same way, right? Whatever transport it came out of, ultimately, that'd be the public IP that it would come back to, and then come into the firewall, unnatted, and then go back to the MPLS router and back to the box. So that, in my opinion, I am in complete agreement that this is a much less complex way to do it, because it doesn't involve having to muck around with our TLOCs and with our tunnels and just with the router in general, right? If possible, this is probably the way to do it. And then go ahead. Sorry.
I was going to say, I typically do see this as the probably more common deployment, where you have routers sitting in front, kind of terminating these transports, rather than, it's just specifically in the data center, right? So it's in the data center, you normally have that kind of capacity that you want these kind of like beefier routers sitting in front of your transports or firewalls, things like that. So you might have like an ASR terminating the internet or what have you to funnel things through the firewall, etc. But it does let you easily segment where things enter the SD-WAN, where they exit the SD-WAN, as well as just build the underlay, because you got to keep those things very, very separate.
Absolutely. No, that's I agree completely, right? So what you see in the data center is often there'll be a CE or some kind of CE connected to the provider, and then at that point it may or may not go to a WAN aggregation block. What I see sometimes is that it'll go to a block, like say, obviously I run out of real estate here, but let's say there was like a switch that then the switch would actually be what connects to the SD-WAN, right? Would you agree with that? So like that, right? And so here, what you would do is on the aggregation block, you'd be running VLANs. So this would be like VLAN 2, VLAN 3, VLAN 4 for, one for each provider. And then you would do the same thing towards the SD-WAN blocks. Like say you did a sub interface or you did 3 separate interfaces, you would tag those interfaces with a VLAN, right? That's right. Commonly how that's seen, right? And I would agree completely with that. And then, so there might be a firewall here, whatever. There's a lot of design that goes into that data center design, right? But from a control connections perspective, 100%. So, okay. So I think we had a really good discussion about control connections in general, and especially like what are the things we have to take into consideration when we build them, and just like what are some of the solutions we could take. So let me bring it back, and let me just bring it back to us talking for a bit, and we'll just close this out. Well, Chris, this was a huge help, and it was a lot of fun, and this was so much more interesting than me jumping through all the options on my own and just telling everybody. And dude, thanks for doing this with me. I didn't know if this was going to work. I think it worked really well. It was really cool to hang out and talk with you about this.
Yeah, of course. I appreciate it. It was really fun. I'm really looking forward to hearing from the rest of the gang that you pull in to talk about this. Yeah, it'll be interesting.
Awesome. So at the end, if I can trick enough other people into doing this with me, I would like to bring everybody back and talk about the design we came up with kind of collaboratively. So yeah, definitely, dude, be bringing you back. All right, man. And thanks to everyone for hanging out with us. And I hope this was cool, fun to watch. Let me know if this format worked for you. Let me know if you enjoyed it. Thanks, guys.
Thanks, guys.